So for these first couple of examples, I'll show both ways to solve them. I'll show the ways where we're just picking a fraction and getting rid of things. And I'll also show the way where you get a common denominator for everything, and then you can just cancel it out that way. So when you watch them later, you can decide which method you like better. Okay? So if I were to get a common denominator for each of these between 2x, 5, and 10x, what would my common denominator be? 10x. So my first fraction, I'd have to multiply top and bottom by 5. That would give me 5 over 10x. The second fraction, I would have to multiply top and bottom by 2x. That would give me 4x over 10x. And the last one is already over 10x. Now, what I'm writing here in black, you wouldn't have to show, because it is kind of tedious to do that. But if you multiplied both sides by 10x, what's going to happen is all of these are going to cancel out. So if you did write them, you would cancel them out as well. And now our equation is just 5 minus 4x equals 1. Subtract 5 on both sides, you get negative 4x equals negative 4, and x is equal to 1. We have to, because it's a rational equation, we have to check what were our non-permissible values. X can't equal 0 in this case, because if x were 0, then we'd be dividing by 0. So our non-permissible value is x can't be 0. Our solution is x equals 1. It works. Now, if we did this same equation by just canceling out fractions as we see them. And some of you might say, I want to cancel out the 10x first. That would cancel out everything. Most people, though, when they're canceling out fractions, they just go to the first fraction they see, and they say, I want to get rid of that one first. So if I multiply everything by 2x, here, that'll cancel out. In the second one, there's nothing in common there to cancel out. But in the third one, my x's will cancel out, and I'll get the fraction 2 over 10, which will reduce to 1 over 5. So I'm going to get 1 minus, this will be 4x over 5, equals, and then this fraction reduces to 1 over 5. So by multiplying everything by 2x, I got rid of one of the fractions. I still have a fraction of 5, and so now I can multiply everything by 5 to get rid of that fraction. These 5's will cancel, and these 5's will cancel, and 5 times 1 become 5 minus 4x equals 1. And now we can see that it's exactly the same as the other equation. So we'd get x equals 1 again. All right, part B. We'll do our techniques in the same order. So if we wanted to get a common denominator here, it would be x squared. So the first fraction is missing an x. The second fraction already has an x squared. The 6 is 6 over 1. It's missing, an x squared and an x squared as well. So if we go that way, we would have 5x over x squared plus 6 over x squared equals 6x squared over x squared. Now, if you multiply both sides by x squared, all of these would go away. And we just get 5x equals 6x squared. How do you solve that? You're going to factor or quadratic formula or solve by completing the square. It's a parabola. It's an x squared quadratic equation. In order to do any of those techniques, we first have to get it equal to 0. Now, you can decide which side you want to get equal to 0. Okay? You could move the 6x squared over and say only one thing has to move, and then I'd have it equal to 0. Or you can move the 5x and the 6 over, and then two things have to move to equal 0. I prefer, because it's easier to factor, if whatever number is in front of the x squared is positive. Just makes it a little bit easier to factor. So I would choose to move the 5x and the 6 over. This is a hard one to factor because both the first number could be 1 or 6 or 2 and 3, and the last number could be 1 or 6 and 2 and 3. There's not that many things to check, but we could try. What should we start with, 1 and 6 or 2 and 3 as a check? 1 and 6? So if I choose 1 and 6, then I'm going to have, and I'll do them in green here. The last ones could be 1 and 6. Does that ever make 5? No, because this will be 6 and 6. That makes 12, or 0. Okay? Be careful, because you might be thinking in your head, if you just use the green 1 and 6, you get a 5. But you have to check outside and inside, right? And with that extra 6 here in the blue, then that 1 actually becomes a 6. So 1 and 6 doesn't work. What about 6 and 1? This will give me 36 and 1. Does that ever make 5? No. So then we'd have to say, well, maybe it would be 2 and 3. I'm glad that you chose this. This will take the longest way possible. We get to do the most mental math. Yay. Now what's my inside is 12. My outside is 3. That doesn't make 5. And if I switch those and put the 3 here and the 2 there, I get 18 and 2. Doesn't equal 5. So that tells us that our initial decision of choosing a 1x and a 6x isn't going to work. So we go back to our initial decision and say, perhaps it was 2x and 3x. And to save you some pain, let's say we try 3 and 2. The inside is 9, the outside is 4. Does that ever make 5? Yes. So now we need a -6 and a -5. So I'm going to make this negative so that my inside is -9, and that'll make my outside +4, makes -5. I do a quick check completely with FOIL to see that it works. Yes, it does. The outside is -6. The last ones are -6. First ones give me 6x squared. And so now that I've factored it, I get that x equals, well, if this was equal to 0, move the 3 over, divide by 2. X equals 3 over 2. And this one, x is equal to -2/3. Yes? You can solve this by completing the square as well. It wouldn't be nice, because you'd have to first factor out the 6, and then you get 5/6 as a fraction. So it wouldn't be a nice one to complete the square. Quadratic formula wouldn't be too bad. This one, in cases like this where the factoring looks like, ooh, I'm going to have to guess and check a lot, you might go and say, the quadratic formula gives me the right answer. It takes a little bit longer than factoring if I get the factoring right away. But if it's looking like this is going to be tough to factor, then let's do that. -b, -5, plus or minus. B squared, -5 squared would be 25, minus 4. A is 6. C is -6. Over 2 times A. 5 plus or minus. 25 plus, this will be 36 times 4. What is that? 1. This is, well, this 169 with the 25 in there? Yeah. Yeah, this will be 169. Yeah, this will be 144. And then divided by 12. So we get 5 plus or minus the square root of 169 is 13. That tells us that it could have been factored once that number is a perfect square. And then you just split it up. The 5 plus 13 would be 18 over 12, which reduces to 3 over 2. The 5 minus 13 would be negative 8 over 12, which reduces to negative 2/3. So that takes a little bit of math too, but you might say to yourself, if the factoring is tough, maybe I'll go to the quadratic formula. The completing the square, I think, of all the methods would be the most miserable, and I wouldn't recommend it. I'll show it to you another time. It's just you'd have to factor out the 6, so you get 5/6, and then divide that by 2 in squares, so you'd have to add 25 over 144, multiply that by 6. Yeah, it's just nasty fractions. Okay, so there are our two answers. We do have to say, do we have any non-permissible values in this? Before we can say that those are both our answers, we look back at our original equation, and x can't equal 0. Neither of those are 0, so they're fine. Both answers are right. No extraneous roots. The other technique for this one is getting rid of fractions. Okay? In this case, I'll just rewrite it. If I use the technique of I want to get rid of fractions, maybe you see I want to get rid of the x first. Sometimes when you're getting rid of fractions, people decide to get rid of the biggest one first. So if I decided to get rid of the biggest thing on the bottom first, which is an x squared, and I multiply everything by x squared, well, for sure, these ones will cancel out, because that's the one I decided to get rid of. An x squared over an x simplifies, and now I'm just left with 5x plus 6 equals 6x squared, which is the same thing as you got on the other one. And the solution would be the same after that. So you get to choose which technique you want to get rid of the fractions. Either getting a common denominator first, and then being able to multiply to cancel them out, or just picking one of the fractions and multiplying and do it over and over again until all your fractions are gone. Questions you can do for this one are 3, 4, 5, and 8.